everyone. Go ahead and open your books to page 187. We're in lesson 12.4 called Slopes of Parallel and Perpendicular Lines. So we are going to be able to describe the relationship among the slopes of parallel lines and perpendicular lines. And then we're also going to write an equation of a line that contains a given point and is parallel or perpendicular to a given line. So what do you think about when you think of parallel lines? Does anybody have any real life or real world examples? Here are some of mine. And what about perpendicular? Where do we see perpendicular lines in nature? Here are some examples as well. So parallel lines and perpendicular lines are pairs of lines that have special relationships. Parallel lines in a plane are equidistant from each other at all points. So if I'm looking at this graph, I see L1, L2, L3, and L4. And we are going to determine the slope of each line. So I want you to go ahead and pause and do that. But make sure that you are putting points on your line or lines. And then make sure you're counting your rise over run and find the slope of all of these. When we're finding the slope from a graph, remember that we are counting rise over run. So line 1 has a slope of 1/2. You could have picked two different points than I did, but as long as we're reducing or simplifying, we all should have gotten 1/2. Line 2 is also 1/2. Both of these slopes are positive because these lines are increasing. Line 3 is down 2 over 3. Line 4 is down 2 over 3 as well. Question 2 says, in the graph above, line 1 is parallel to line 2, and line 3 is parallel to line 4. Do we agree with that? L1 and L2 are parallel, L3 and L4 are parallel. So what can we say about the slopes of parallel lines? What do we notice? Well, we notice that slopes of parallel lines are the same. L1 and 2 are the same, L3 and 4 are the same, and they were parallel. That makes sense because they're never going to touch each other or intersect. Just like railroad tracks. Just like the lines on your paper. Question 3. Determine the slope of a line that is parallel to the line whose equation is y equals negative 3x plus 4. Well, what's the slope given? The slope here is negative 3. So a line parallel to that is also going to be negative 3. It has to be the same. So if I said I have a line with the slope of 22, a line parallel to that is also going to have a slope of 22. They're always going to be the same. Question 4. Write an equation of a line that is parallel to this line right here, and it has a y-intercept of 5. Well, I could get my slope and my y-intercept. So we're going to write this in slope-intercept form. Y equals mx plus b. What would be my m? What would be my slope? If it's parallel, it has to be the same. So it would be 3 over 4 x plus 5 is my new y-intercept. It cannot be -1 or -1. That would be the same exact line. I don't want the same line. I want a line parallel to that. So make sure you use the new y-intercept here of +5. Okay, and then we have the same slope, 3/4. Any questions? Number 5, horizontal lines are described by equations of y equals a number. For example, the x-axis is y equals 0. Okay, so horizontal lines look like this. Why would these be parallel? Why would any horizontal lines be parallel? They all have the same slope, which is 0. Remember Mr. Slope Dude? This is 0 fun. Vertical lines are all these x equals a number. So for example, the y-axis, which is vertical up and down, is x equals 0. And all vertical lines are parallel because they all have the same slope, which is undefined. And we're going to skip question 7, which kind of goes along with 5 and 6. But let's jump to question 8. A line is parallel to y equals 3x plus 2, and it passes through this point 1, 4. What is the slope? The slope is 3. How did I know? Well, because it's parallel, it has the same slope. And it says write an equation of the line. I know the slope and I know a point. So let's choose point slope form. That would be the easiest. Here's my x1, y1, and just a reminder of point slope form. This is why we have that one note sheet with all of the forms on it. They're also posted at the front of my classroom for you. So we have y minus our y1 is 4 equals my slope, my m is 3, parentheses x minus our x1 is 1. It didn't say slope-intercept form, so let's choose the easiest or the one that makes the most sense, which is point slope. Okay, question 9. We're going to do a bit of graphing in the My Notes section of your book. They gave you a graph. So we're going to draw a L5, line 5, and it has a slope of -4/3, and it contains a point 0, 2. So let's plot 0, 2, which happens to be a y-intercept, 0, 2. And our slope is -4/3. So let's go down 4 boxes over 3. And it was a negative slope, so my line has to be decreasing. And we're going to keep going. Down 4 over 3. Down 4 over 3. And we want to have as many points as possible on our graph. So let's start at our y-intercept 0, 2, and let's go up 4 over 3 the other direction. Now I want you to use a straight edge. Be really accurate and connect these points. And let's label it L5. Line 6 contains the point 0, 0, so at the origin. And it has a slope of -3/4. -3/4. So down 1, 2, 3 over 1, 2, 3, 4. Keep going. Up 1, 2, 3, 1, 2, 3, 4. And again, use a straight edge and connect those. And go ahead and do L7 as well. So question 9 says, which lines appear to be perpendicular? Well, we need to talk about what perpendicular is. Okay, perpendicular means that the lines cross to form 90-degree angles. Now, this is a really hard example to tell. And when I'm looking at the paper version, it's a little bit easier to tell than on the board. But the correct answer here is line 5 and line 7, although it doesn't look like it. To me, right now, it looks like line 6 and line 7, but on my paper, it looks like line 5 and line 7. So this is why I don't love this question in the book, because it is really tricky. Okay, so the correct answer for number 9 is line 5 and line 7. And if you tilt your head, okay, hopefully you did a really good job of graphing, and hopefully this forms a really good 90-degree angle right here in your book on your piece of paper. Hopefully you used a ruler or a straight edge. Okay, and then these are not 90-degree angles here. Hopefully yours is more precise than mine on the smartboard. So, if you look at the slopes of line 5 and line 7, I want you to tell me what you notice. What do we notice? What could we say about the slopes? The slopes of perpendicular lines. This sign means perpendicular. Two things. The first thing we notice is that one of them is negative and one of them is positive. So we're going to use the word opposite. Okay. opposite. They have opposite signs. Slopes of perpendicular lines are opposite. One's positive, one's negative. What else do we notice? Our fractions are flipped. Okay, one has 4 in the numerator, one has 4 in the denominator, and vice versa. So the fancy word for that is reciprocal. So the slopes of parallel lines are opposite reciprocals. One's positive, one's negative, and we have to flip the fraction. Flip the fraction. Okay? Flip the fraction. So for question 11, I'm going to help you come up with examples. Oh, let's go back. Maybe I took out question 11. All right, we're going to skip question 11. Jump to 13. That means I've skipped it in the past. Question 13. We have a line that contains the points 0, -1, and 3, 1. And it's perpendicular to line 2 that contains the point -1, 2. We need to find the slope of each line. Well, let's find the slope of line 1 first, between these 2 points. Well, how do we find the slope between 2 points? We have the slope formula, right? y2 minus y1, x2 minus x1. So y2 minus y1, let's write that down first. So we have 1 minus a -1. 2 negatives make a positive, so 1 plus 1 is 2. Divided by, in the denominator we have our x's. So 3 minus 0, which is just 3. Okay, so this is the slope, it doesn't reduce or simplify, of line 1. But we have to find the slope of each line, so we need the slope of line 2 now. Well, what do we know about line 2? We know it contains the point -1, 2, but that doesn't help us with the slope. We do know that it's perpendicular. So, they have to be opposites. So if this slope of line 1 is positive, line 2 has to be negative, remember? And they have to be reciprocals, so we need to flip the fraction. So let's flip it. Okay, let's flip it. 3 is now in the numerator, 2 is in the denominator. All right, one moves upstairs, the other one moves downstairs. They're changing places. Does that make sense? So this is the slope of line 2. All right? Now, let's write an equation for both of the lines. So here's line 1. We know the slope. What else do we know? What could we call this? It's a point, yes, but what kind of point is it? It's the y-intercept. So let's write it in slope-intercept form. Y equals my m, my slope, which is 2/3 x. And what's my y-intercept? -1. Perfect. Line 2. We know the slope, and we know a point x1, y1. So hopefully you have your point slope notes out in front of you. So y minus y1, which is 2, equals m, the slope, parentheses x minus my x1, which is a -1, but two negatives make a positive, so plus 1. So one of them is in slope-intercept, one of them is point-slope, and we can leave it like that. It didn't say we had to choose a certain way to write it, so let's use the easiest one. Now, we could have written line 1 in point-slope if we use this, x1, y1. Doesn't matter. I would have taken both answers if this was homework or a quiz. Okay, question 14. I want you to look at A, B, C, and D. They're giving you two different slopes, which is why they're labeled M1 and M2. And you're going to look at these slopes, and you're going to write down parallel, perp, or neither. Okay, some people use this for parallel, and then the perpendicular symbol is like this. Some students write PAR and PERP. But go ahead and do 14A through D. Parallel, perp, or neither? So 14A, are they exactly the same? No. So they're not parallel. Okay. Are they opposites? Is one positive and one negative? Yes. Are they reciprocals? Could I flip them? Well, think about, if this is 1 over 4, could this be 4 over 1? Yes. All whole numbers are being divided by 1. All integers are being divided by 1. We just don't write them. So letter A, these are perpendicular. They're opposite reciprocals. Letter B, are they exactly the same? No. So they're not parallel. One's a -3 and one's a +3. So they're opposites. One's negative, one's positive. But are they reciprocals? Is one of them flipped? No. So this is neither. In order for them to be perpendicular, okay, we would need to have a 1/3 and a -3, or a -3 over 1, something like that. So this is neither. This is neither. Question C. I forgot about how tricky this one was. Sorry. Let's reduce this first slope. So 10 divided by 2 is 5. 12 divided by 2 is 6. Sorry about this. All right, let's change this mixed number into an improper fraction. So 5 times 1 plus 1 is 6. So the second slope would be -6 over 5. Now look at them and say, are they parallel, perpendicular, or neither? Are they exactly the same? No, so they're not parallel. Are they opposites? Yes, one's positive, one's negative, so we check off that box. And is the fraction flipped? 5 and 6, they flip places, so yes, this is perpendicular. Sorry, I won't give you that much of a tricky one on your homework. And question D, everybody, what is it? Parallel, why? Because they are exactly the same. Up 1 over 2, they're never going to intersect. All right. Let's jump down to question 17. 17. So 17 says write an equation of a line perpendicular. That's always important to read. Perpendicular to this line. So right away, let's stop right here. What do we know about perpendicular? Well, we can determine our slope. Okay, so what's the slope of the line given? The slope here is 5, or 5 over 1. So what would be our slope perpendicular to that? The slope given is positive, so our new slope is negative. And then let's flip it. Negative 1 over 5. Okay, so that's our new slope, and then we're given this point x1, y1. So we have the point, we have the slope. Let's do point slope form. Okay? So y minus y1 equals slope, parentheses x, minus x1, which is negative 10. Two negatives make a positive. And that is where we will stop today.